Hello student, in this video we will see the exercise 2.3, that is sum of the infinite terms of the geometric series. That is S is equals to A in bracket R raised to n minus 1 upon R minus 1 when R is greater than mod of R is greater than 1. When mod of R is greater than 1, then sum tends to infinity, and when mod of R is less than 1, then sum can be written as S is equals to A upon 1 minus R. This type of the examples we will see in this. I had explained all the examples in a very simple language, and all the types of the problems are explained with it given, and there are more and more calculation. I hope that all of you understand whatever I am explaining in this video. Now let us start exercise 2.3. Now let us start sum of infinite terms of geometric progression. Number of the students say that, sir, explain the basic concept before the chapter. Now again I am explaining, but also I had explained number of the videos before I start the chapter main points. Now see this, let us consider the geometric progression 1, 3 by 4, 9 by 16, 27 by 64. In this case A is equals to 1, R is equals to 3 by 4. This is the common ratio, and this common ratio is 3 by 4, and which is less than 1. Again I had applied there that 3 by, how it is a 3 by 4, that is 3 by 4 upon 1, 9 by 16 upon 3 by 4. Overall it is a 3 by 4. That is in the definition of T1, T2, that is the T2 upon T1 is equals to R. Now see this, Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. Now how to find the sum of the infinite terms? That is, now we will substitute here A is 1, 1 minus 3 by 4 bracket raised to n upon 1 minus 3 by 4. That is 1 minus 3 by 4 bracket raised to n, and 1 minus 3 by 4 is 1 by 4. Now again multiplied and reciprocal, it becomes 4 in bracket 1 minus 3 by 4 bracket raised to n. Now how to find the value of, that is a 3 by 4 bracket raised to n? Let us study behavior of 3 by 4 bracket raised to n. Means what? Bracket raised to 1, bracket raised to 2, how their values are becoming less and less and less. Now 3 by 4 means what? 0.75 if n is equals to 1. As n becomes larger and larger, the first power is 0.75. Now second power, that is a 9 upon 6, that is, it had taken the derivative. Next power, the values are becoming, that is the fifth power, less and less. We take again 10th power, then its value become, that is a 0.056 31352. And if we take again the 20th power, its value become 0.0031712, and in this way, as the value of n becomes larger and larger, the ratio R, the value of larger and larger, the value of the fraction becomes less its value becomes less. When n becomes indefinitely, then 3 by 4 raised to n tends to 0. Means what? Its value is 0. Therefore, here we will write here, that is Sn is equals to r raised to n becomes 0, means to the numerator only the term is 1 into a, that is a, upon 1 minus r. Therefore, whenever there is a geometric progression and the value of r, mod of r is less than 1, therefore Sn, their sum is taken as a upon 1 minus r. Now this is due to the computer screen, that is a upon 1 minus r minus a in bracket 1 minus r raised to n, and that value becomes 0 because r raised to n is a smaller and smaller, and overall therefore Sn is equals to a upon 1 minus r for mod of r is less than 1. This is the formula you have to remember only. But anyone will say that if the value of r is mod of r is greater than 1, then what will happen? Then r minus 1 is constant, denominator will be the constant, but r raised to n becomes very large as n approaches to infinity. Therefore, their sum tends to infinity when mod of r is greater than 1. So, the infinite terms cannot be sum up to n. Therefore, here we will consider only those cases the value of mod of r is less than 1. Determine whether the sum to the infinity of the following GP exists. If exist, find them. Now see this, the sequence geometric progression, that is 1 upon 2, 1 by 4, 1 by 8, 1 by 16. Now here a is equals to 1 upon 2, r is equals to 1 by 4 upon 1 upon 2, that is equals to 1 upon 4 into 2 upon 1, that is 1 upon 2. Therefore r is equals to 1 upon 2, mod of r is less than 1, and therefore is equals to 1 upon 2, which is less than 1. Therefore sum is equals to a upon 1 minus r. The value of a is 1 upon 2 minus 1 upon 2, and that's why 1 upon 2 upon 1 upon 2, overall it becomes 1. Therefore the sum is equals to 1. Now the next problem is 2, 4 upon 3, 8 upon 9, 16 upon 27, and in this way a is equals to 2, r is equals to 4 upon 3 upon 2. That is 2 is nothing but 2 upon 1, that is 4 by 3 into 1 upon 2. It becomes 2 upon 3, and the value of the r is again less than 1. Therefore sum to the infinite exists, and it is s is equals to a upon 1 minus r. Sum to infinite terms is finite. Therefore s is equals to a upon 1 minus r, 2 upon 1 minus 2 by 3. Very simple exercise. Therefore you get, that is the 2 upon 1 into 3 upon 1, that is s is equals to 6. Now Third, minus 3, 1, minus 1 upon 3, 1 upon 9, and in this way, a is equals to minus 3, r is equals to 1 upon minus 3, that is a minus 1 upon 3. Mod of r is equals to 1 upon 3, which is less than 1. Therefore, sum to infinite term is finite. Always write this type of a sentence when mod of r is less than 1. And their sum is equals to s is equals to a upon 1 minus r, that is minus 3 upon 1 minus in bracket minus 1 by 3, that is minus 3 upon 1 plus 1 upon 3, and overall you are getting minus 1 upon minus 3 upon 1 into 3 by 4, that is a minus 9 by 4. This is the s, this is the sum which is finite. Therefore, next is s is equals to minus 9 by 4. This very again simple, that is a s is equals to, that is 1 by 5 minus 2 by 5 minus 2, 1 by 5 minus 2 by 5, 4 by 5 minus 8 by 5, 16 by 5, and in this way, here again a is equals to 1 upon 5, r is equals to minus 2 by 5 upon 1 by 5, and overall it becomes minus 2. Now what's happening here? Mod of r is equals to 2, which is greater than 1. Therefore, the sum to infinity do not exist. It will become infinite. Therefore, we do not require to find out their sum. Now next is 8, 81, 7.8. Next is 9, 8.1, 7.29, and in this way r is equals to 8.1 upon 9, which is 81 upon 90, that is a 9 upon 10. Again, mod of r is equals to 9 upon 10, which is less than 1. Sum to infinite terms is finite. Therefore, s is equals to a upon 1 minus r, that is a 9 upon 1 minus 0.9, that is a 9 upon 0.1, and that is equals to. Express the following recurring decimals as a rational number. This type of the problems you have to in the 9th standard, that is 0.7 recurring, that is it is written as 0.7777, and it can be written as, that is 0.7 plus 0.07 plus 0.007, and in this way. Now if you see this is again in the geometric progression. A is equals to 0.7, r is equals to 0.07 upon 0.7, and that's why you will get the value 7 upon 70, that is 1 upon 10. Therefore, it is a 0.1. Therefore, mod of equals to 0.1, which is less than 1. Therefore, the sum exists. Therefore, sum is equals to a upon 1 minus r, 0.7 upon 1 minus 0.1, that is 0.7 upon 0.9, which is 7 upon 9. This is the sum. Sum is equals to 7 upon 9. Now next is 2.4 bar, that is 4 is recurring there. Therefore 2 plus 0.4444. Again it is written as 2 plus 0.4 plus 0.04 plus 0.004, and in this way. Now we have to keep aside, then we'll add these two, but first we will find out s. That is not 2, a is equals to 0.4. What about the r? the r will be again mod of r is equals to 0.04 upon 0.4. That is, it is again 1 upon 10 means what? 0.1. The value of r is 0.1, which is less than 1, and sum to the infinite terms exist and it is a finite. That is, the sum to infinite term is finite and is s is equals to again a upon 1 minus r. That is, the value of a is 0.4 upon 1 minus 0.1, that is 0.4 upon 0.9, which is 4 upon 9, and therefore it is, first of all we have the number 2, therefore 2 plus 4 upon 9, which is 22 upon 9. Now the next is third one, that is a 2.35 recurring there. Therefore we write this number like this: 2.3 plus 0.055555. That is a 2.3 plus 0.05 plus 0.005 plus 0.0005, and in this way. Here a is equals to 0.05, r is equals to 0.005 upon 0.05. Overall you are getting 5 upon 50, and which is nothing but 1 upon 10, and that is 0.1, and which is less than 1. Mod of r is less than 1. Therefore sum to infinite term is finite. Therefore s is equals to a upon 1 minus r, that is 0.05 upon 1 minus 0.1, which is 0.9, and hence again we will get, that is a 5 upon 90, that is multiplied numerator and denominator by 100, you will get 5 upon 90. This is the value of s, or you can give their division. So that is a 2.35 recurring, that is a 2.3 plus 5 upon 19. Now we will calculate this again by the multiplication: 2.3 into 19 plus 5, then you will get 212 upon 90, and again we can give the division by the 2, you will get 106 upon 45. Now the fourth is, that is 51.02 bar, means 2 is a recurring there. That is 51.0 plus 0.02 plus 0.002 plus 0.0002, and in this way. Therefore 51 plus 0.02 0.002, and in this way 302. Therefore here again a is equals to 0.02, r is equals to 0.002 upon 0.02. Now if we multiply again by 1000, you will get 2 upon 20, that is nothing but 1 upon 10. Therefore the value of r is 0.1, which is less than 1. Therefore the sum to the infinite term is finite, which is s is equals to a upon 1 minus r, that is 0.02 upon 1 minus 0.1, which is 0.02 upon 0.9, which is nothing but 2 upon 90, that is nothing but 2 upon 1 upon 45, and that's why 51 plus 1 upon 45, we can calculate the value, that is at 2296 upon 45. Now next is, if the common ratio of GP is 2 upon 3. Some terms will be given, some will given, then find the value of a, and the sum to the infinity is a finite, which is a 12. Find the first term. There is a problem for me in the writing. Find the first term, that is a. Here what is given, that is r is equals to 2 upon 3, s is equals to 12, a is equals to question mark, therefore apply the formula. S is equals to a upon 1 minus r, that is 12 is equals to a upon 1 minus 2 upon 3, that is a upon 1 upon 3, and after the calculation 12 into 1 upon 3, that is equals to 4. Therefore a is equals to 4, which is the first term. If the first term of the GP is 16 and its sum to infinity is 96 upon 17, find the common ratio. Therefore, given a is equals to 16, s is equals to 96 upon 17. Therefore, s is equals to a upon 1 minus r. Therefore, 96 upon 17 is equals to 16 upon 1 minus r. Now, their cross multiplication, that is 1 minus r is equals to 16 into 17 upon 96. Again, by the simplification, you will get r is equals to 1 minus 16 into 17 upon 96. That is 96 minus 272 upon 96. That is 176 upon 96. And again, after the simplification, you will get minus 11 upon 6. Therefore, r is equals to minus 11 upon 6. This is the ratio. Now, question number 5. The sum of an infinite GP is 5 and sum of the squares of these terms is 15. Find the GP. Let A be the first term and R be the common ratio. Therefore, the terms of the infinite geometry geometric progression, then the geometric progression is AR square, AR cube, and dash dash next terms. But we have given the condition sum to infinity of this GP is 5. Therefore, A upon 1 minus R is equals to 5. The sum of squares a upon 1 minus r is equals to 5. Now sum of the squares of these terms is 15. Now sum of the squares of these terms, first term is a square, therefore a square, first term is a square, a square r square, a square r raised to 4, a square r raised to 6. This is also infinite geometric progressions. This is very important. Whatever the given terms, make their squares and add these. This is also infinite geometric progression whose first term is a square and the common ratio is r square. Since mod of r is less than 1, mod of r square is also less than 1, and the sum to infinity of this GP is finite, is a 15, which is the finite. Therefore a square upon 1 minus r square. At that time we take the ratio a upon 1 minus r. Here we will take a square upon 1 minus r square. That is equals to 15. But we also have, that is in first condition, a upon 1 minus r is equals to 5. And a square upon 1 minus r square is equals to 15. Now solve these two equations. We will get the value of a and the value of r. Therefore a is equals to 5 in bracket 1 minus r, and after multiplication you will get a square is equals to 15 in bracket 1 minus r square. This is number 2. Squaring on both sides, a square is equals to 25 in bracket 1 minus r bracket square. Therefore a square is equals to 15 in bracket 1 minus r square, and after evaluating you will get, that is a 5 in bracket 1 minus r into 1 minus r, and that is, we write in this manner, that is equating these two terms, that is divide on both sides by 5, then in place of 25 you will get 5, in place of 15 you will get 3. 1 minus r bracket square can be written as 1 minus r into 1 minus r, and on the right hand side 1 minus r square means what? 1 minus r into 1 plus r. Now the cancellations. Therefore you will get 8 is equals to 8r. Therefore the value of r, that is a 5 minus 3 is equals to 8r. Therefore 2 is equals to 8r. That is, therefore r is equals to 2 upon 8, which is equals to 1 by 4. But a upon 1 minus r is equals to 5. Therefore a upon 1 minus 1 upon 4 is equals to 5. After simplification, a upon 4 minus 1 upon 4 multiplied and reciprocally you will get a upon 3 by 4. Or you simplify like this, a is equals to 5 into 3 by 4, that is 15 by 4. This is the value of a. Now the next is the term of GP are AR square, that is 15 by 4. This is the first one. 15 by 16, 15 by 64. Now the next. Find question number 6. Summation r is equals to 1 to infinity 4 0.5 bracket raised to r. Now for summation r is equals to 1 to infinity 0.5 bracket raised to r and can be written as 0.5 plus 0.5 bracket square plus 0.5 bracket cube and dash dash. Here a is equals to 0.5, r is equals to 0.5 because 0.5 bracket square upon 0.5 is equals to 0.5, which is nothing but 5 upon 10, and that is equals to 1 upon 2. The value of r is equals to 1 upon 2, mod of r is equals to 1 upon 2, and which is less than 1. Therefore, s is equals to a upon 1 minus r, that is 0.5 upon 1 minus 0.5, that is 0.5 upon 0.5, that is equals to 1. Therefore, the sum s is equals to 1. Therefore, it is a 4 into s. Therefore, 4 into 1, that is equals to 4. Therefore, 4 summation r is equals to 1 to infinity 4 into 0.5 bracket raised to r is equals to 4. Now the next is summation r is equals to 1 to infinity 4 into in bracket 0.5 bracket raised to r is equals to 4. These are the problems. Now we'll see again the next problem. Here we apply the formula, that is s is equals to a upon 1 minus r. Now second, r is equals to 1 to infinity minus 1 upon 3 bracket raised to r. Now here minus 1 by 3 bracket square minus 1 by 3 bracket cube, a is equals to minus 1 by 3 and r is equals to minus 1 by 3 bracket square upon minus 1 by 3, and that is r is equals to minus 1 upon 3. Now mod of r is equals to mod of minus 1 by 3, which is less than 1. Therefore again s is equals to a upon 1 minus r, that is minus 1 by 3, 1 minus in bracket minus 1 by 3. That is equals to minus 1 by 3 upon minus minus will become plus, it is again 2, 4 by 3, 3 get cancelled, and then you will get minus 1 upon 4. This is s. Now next, now this is third one. The answer given in the textbook is different from my answer. If you are agree, then you maybe agree here. If you are not agree, then you do not agree with this answer. But I had shown very accurately r is equals to 0 to infinity minus 8 minus 1 upon 2 and bracket raised to n. This is the writing problem. Therefore, that is minus 8 is constant. Therefore, we can write it is outside, that is summation term. That is first minus 8 in summation r is equals to 0 to infinity minus 1 upon 2 raised to n. And that is minus 8. Then in the next bracket, what is happened? Suppose that r is equals to 0 to infinity minus 1 upon 2 bracket raised to n. Here minus 8, and the terms will be like this. If I take r is equals to 0, then minus 1 upon 2 raised to 0 is 1, minus 1 upon 2 raised to 1, minus 1 upon 2 raised to 2, and in this way. Now we will find out the sum of the 1 plus in bracket minus 1 upon 2 plus in bracket minus 1 upon 2 bracket square, and in this way. Here a is equals to 1, r is equals to minus 1 upon 2. This is the ratio. Now we will find out, that is mod of r is equals to 1 upon 2, mod of 1 upon minus 1 upon 2, which is less than 1. Therefore the sum to infinite terms is finite. We have to write every time this dialog. Therefore, S is equals to A upon 1 minus R, that is 1 upon 1 minus in bracket minus 1 upon 2, that is 1 upon 1 plus 1 upon 2, that is 3 by 2. S is equals to 2 by 3. Therefore, R is equals to 0 to infinity minus 8 minus 1 upon 2 raised to n, that is it. And it is nothing but the minus 16 upon 3. But the answer in the textbook given is different from my answer. If you like this, or if you have the confidence, then write this. If you do not have the confidence, then you keep it as it is. Therefore, the summation is a minus 16 upon 3. I had written there. Now the next one is fourth one. Summation n is equals to 1 to infinity, that is 0.4 bracket raised to n is equals to 0.4, 0.4 bracket square, 0.4 bracket cube, and in this way. Therefore, the answer of this question is different from the textbook, but I had solved. A is equals to 0.4 and the value of R is 0.4 upon 0.4 bracket square upon 0.4. And its value is 0.4. It is nothing but 4 upon 10, which is 2 upon 5. R is equals to 2 upon 5. Therefore, is nothing but 0.4. S is equals to A upon 1 minus R. 0.4 upon 1 minus 0.4, that is 0.6. That is nothing but 4 upon 6, which is 2 upon 3. Therefore, S is equals to 2 upon 3. This is again, the answer is different from the textbook. That's all. Next, question number 7. This is very nice question. The midpoints of the sides of a squares of side 1 are joined to form new square. This procedure is repeated indefinitely. Find the sum of first the areas of all the squares, second the perimeter of all squares. Now the first answer is different. My answer and the textbook answer is different, but the second is match one. Now we'll see how it is. Now see this square, first square whose side is 1. Now take the midpoints of the sides of the square and join. This is the new square. Now the diagonal of the new square is 1. Therefore, we want to find out the side. There is a question mark I had written. Therefore, the side is equals to diagonal upon root 2, that is 1 upon root 2 is the side of the new square. The side of the first square is 1 and the side of the second square is 1 upon root 2. Now the next square is again join the midpoints of that square, then you will also get this is the diagonal, and then that diagonal will coincide again the 1 by root 2. Therefore, I had written with the red ink. Therefore, its side is 1 upon root 2 into diagonal, that is, but the diagonal is 1 by root 2, therefore 1 upon root 2 and 1 upon root 2, that is it is 1 upon root 2 bracket square instead of 1 upon 2, but I am changing that. This is 1 upon 2. Therefore, again next square, therefore again the side is 1 upon root 2 into 1 upon root 2 bracket square. Now I am changing here. The side of that square, blue square, that is 1 upon root 2 into 1 upon root 2 and bracket is square. Therefore, I am changing here. Therefore, it becomes 1 upon root 2 bracket raised to 3. Now, the sides of the squares are first is 1, second is 1 upon root 2, third is 1 upon root 2 bracket square and 1 upon root 2 bracket raised to 3. These are the sides of the squares. Now there is a problem in writing. Now see this. 1 upon root 2, 1 upon root 2 bracket square, 1 upon root 2 bracket raised to 3. These are the sides of squares. We want to find out their area and the perimeter. These are the sides of squares. Their areas are 1 square, 1 upon root 2 bracket square, 1 upon root 2, that is the squares of their sides. 1 square, 1 upon root 2 bracket square, 1 upon root 2 bracket square raised to 2, because the area of the square is side square raised to 2. Therefore, we are getting that is equals to 1 upon root 2 bracket square, 1 upon root 2 bracket raised to 4, 1 upon root 2 bracket raised to 6. This is in GP. A is equals to 1, R is equals to 1 upon root 2 bracket square, and mod of R is less than 1. Therefore, S is equals to sum of area A upon 1 minus R, that is 1 upon 1 minus 1 upon root 2 bracket square, that is 1 upon 1 minus 1 upon 2, that is 1 upon 1 upon 2, that is equals to 2. Therefore, area is equals to 2 square unit. Now the perimeter. Perimeter of all the squares. Now the perimeter of all squares. Therefore, this is the correct correction in answer. Now this is, I had find out the answer. You may agree or may not agree. If you like these steps, I hope that there is no any mistake. Now the perimeter is, now the sides of the squares are 1, 1 upon root 2, 1 upon root 2 bracket square. Here a is equals to 1, r is equals to 1 upon root 2, which is mod of r is less than 1. Therefore s is equals to, that is perimeter of all the squares is equals to 4 into sum of the sides of the all the squares. That s is equals to a upon 1 minus r. That is 1 upon 1 minus 1 upon root 2. Now if we simplify this, then root 2 minus 1 to the denominator and the numerator is a root 2, or in the simplified form, again I am writing here, that is 1 upon root 2 minus 1 upon root 2, that is a root 2 upon root 2 minus 1, and that's why the perimeter is 4s, that is a 4 root 2 upon root 2 minus 1 unit. This is the perimeter, 4 root 2 upon root 2 minus 1. Now there is a small problem. Now next is, a ball is dropped from height of 10 meter. It bounces to height of 6 meter, then 3.6 meter, and so on. Find the total distance traveled by the ball. Therefore, a is equals to 10 here, that is first bounce was there, then 6, 3.6, therefore r is equals to 6 upon 10, that is 0.6. Again we will calculate r, that is 3.6 upon 6 is, that is 0.6 again. Therefore this is very simple problem, and the answer and my answer, textbook answer, and both are coinciding here, same. Therefore the total distance traveled by ball is a upon 1 minus r. A is 10, 1 minus 0.6, that is a 10 upon 0.4, and that is nothing but 100 upon 4, that is a 25 meter, and this is the total distance traveled, the total distance traveled by that ball when that ball bounces. And in this way we have completed the exercise 2.3. Many students are writing in the comment section, that is, sir, explain some basic terms also, and I had also explained before that, but I will now see more and more to explain the basic terms also. And in this way we have completed the practice set 2.3. If you have again any doubt, then write in the comment section. Now we'll see in the next video. Till then, goodbye. Now I will complete this total chapter. Okay, we'll see again next video. Till then, goodbye. In this way I had explained all the examples. I hope that you understood all the problems. If you have any doubt, write in the comment box. Whenever I will have the time, then I will give the answer. I will try to give the answer to your questions, your queries. And again, If you are new for this channel, then subscribe it and share it with your needy friends. And if you like it, then like it. Now we'll see in the next video. Till then, goodbye.